This lesson for Algebra 2 is Lesson 2.5, Using Linear Models. Sometimes it is possible to model data from a real-world situation with a linear equation. You can then use the equation to draw conclusions about the situation. And that's the piece that's really important, is if we have a set of data, we can draw conclusions based on what the data says. So let me demonstrate what I mean. Suppose 6 different women went to buy milk at different stores in Wilmer. Jane bought 2 gallons and they cost $6.94. Maria bought 3 gallons for $12.06. Nancy bought 4 gallons for $14.36. Carol bought 3 gallons for $11.37. Deb bought 2 gallons for $7.98. And Lisa bought 5 gallons for $16.25. So the question becomes, because of all of this data, how much should I expect to buy 12 gallons of milk for in Wilmer? So how much is it going to cost in Wilmer to buy about 12 gallons of milk? Now, of course, it's going to depend on where we go, but we can get an approximation based on the data we've gathered from these women. So I've summarized the information from the amount of milk that we've got in the top left-hand corner. So what we're going to do is we're going to start with graphing this data. So starting out, we've bought 2 gallons for $6.94. So 2 gallons on my graph cost $6.94. So I'm going to put a dot about there to represent the first women. 3 gallons for $12.06. So 3 gallons for $12.06 is about there. 4 gallons for $14.36. 3 gallons for $11.37, and 2 gallons for $7.98, and 5 gallons for $16.25. All right. So now that I have all of my data collected, what we can do is draw a line of best fit. Called a correlation line or a line of best fit through the data. Now I want you to notice that the data kind of mirrors a linear model, meaning that if I were to draw, I could draw a line through it. They're kind of in a line or in a close line. So I'm going to do my best to draw a straight line through this data, and that line is going to approximate the data or the prices. Okay, so then what we're going to do is we're going to use this to figure out, well, about how much are 12 gallons going to cost. So I'm going to go straight up from 12 to my line, and notice that it crosses at about there, and if I go over to my y-axis, let me extend it here, this would be $36, and this would be $39. We can kind of see that 12 gallons of milk would be somewhere between this $36 to $39 for the 12 gallons. So we can make an approximation. I'm going to just say about $38. Okay. Alright, so what we've created are called scatter plots. So I want you to remember that. A graph of data is called a scatter plot. And scatter plots are raw data, and we can use them to make predictions given a situation. Now, some data has very strong correlation. So if we take a look at this graph at the left, we can see that this is very much increasing, and the dots are close to this line of best fit that I've drawn in. So we call that a strong positive correlation. In my second graph on the right, we can see that everything's kind of in this positive direction, but the data is not really tight, so we call that a weak positive correlation. Here we have a strong negative, so they're all pretty close, so we have a strong negative correlation because it's decreasing, and then we have kind of a weak negative on the right. Sometimes data just plain doesn't have a correlation at all. If you look at the dots, they're all over the place, and we cannot make any prediction based on data that has no correlation. Alright, so we're going to take a look at this example. So the cost of a home in Minnesota in thousands. So in here we have the year, and 1 represents 2001, 2 represents 2002, 2003, 2004, and so on. So on our x-axis, we have the years from 2001 to 2010. And then on the y-axis, the vertical axis, we have the cost of a home. And it starts at $85,000, $90,000, $95,000, and so on. And as we look at this graph here, we can kind of figure out, well, what should this home be worth, maybe in 2025? So what we're going to do is we are going to draw in a line of best fit. Now, your line of best fit just has to go kind of through the middle of all of this data. So here's my line of best fit, and I want you to notice that my line ended up going through a couple of the points in my data. So what we're going to do is we're going to create an equation of this line based on those points of data. So there's a couple of things we need. First of all, we need to know the coordinates of the points. So I'm going to start and use this point to begin with. So in 2008, we have 2008. The cost of this home was about $115,000. Now I also noticed that my line went through this point. And so in 2002, the cost of this home was about $95,000. So our goal here is to be able to write an equation of this line so we can use it to predict. Once we have 2 points, we can find 2 things. We can find the slope, and then we can also write an equation. So using these 2 points, we're going to find the slope. So I'm going to let this be my x1, y1, and this be my x2, y2. So in the slope formula, y2 minus y1 over x2 minus x1, I can find the slope of this line. So y2 is 115, subtracting y1, which is 95, over x2, which is 8, minus x1, which is 2. 115 minus 95 is 20, over 8 minus 2, which is 6. And 20 divided by 6 is 10/3, or 3 1/3. So my slope is 10/3, or 3.3 repeating. Okay, so that's the first thing we need to find. The second thing we're going to do is write an equation of this line. So on my next slide, I'm going to choose to use the point 295. So we have the point 295, which represents the year 2002 and the cost of a house, which is $95,000. And then we found out that the slope was 3.3 repeating. So I'm going to start with point slope form because I have a point and a slope. And I'm going to write this equation. So my point 295 is my x1, y1. So I have y minus 95 equals 3 1/3 times x minus 2. So this is an equation of my my line of best fit. So I'm going to distribute 3.3 repeating, or 3 1/3 x, and 3 1/3 times -2 is -6 2/3. I'm going to add my 95 over, and I get 3 1/3 x, 95 plus 6 plus -6 and 2/3 is 88 1/3. Okay, so here we have an equation of our line. So now let's talk about what it means. First of all, the slope of the line is a rate of change. It's how this line is changing. So within this context, because the slope is 3 1/3, that means that every year the value of the home is increasing by $3,133,000. Okay, so that's helpful because it's kind of how fast this is changing. All right, so now we're going to use our equation to predict how much is this house going to be worth in 2025. Okay, now if you notice, X was 1, 2, 3, and 4, and 1 represented 2001, 2 represented 2002, and so on. So if we want to approximate the value of a house in 2005, we are going to substitute 25 into our equation. Alright, so 3 1/3 is 3.3 repeating, so I'm just going to use 3.3 times 25, and 88 1/3 is about 88.3, so I'm going to use that. And I'm going to go ahead and calculate that. And I get y to be 170.8. Now remember, this is in thousands, so I'm going to move my decimal point over and add 2 zeros. So the cost of a house in 2020, this house is going to be about $170,800. So that's a pretty accurate guess as to what this home should be valued in just a few years. So this lesson is all about being able to model relationships. So when you get to class, we are going to do a few more models like this, and I'm also going to show you how to use your calculator to create these equations, or linear regression lines is what they're called. We will see you in a couple days.